welcome back to my channel. Today we're diving into one of the most thrilling topics in physics, rotational motion and bunkers. We'll spin through the theory, break down the formulas, and tackle a real-world problem together. So grab your notebooks and let's roll. First things first, what exactly is rotational motion? When an object spins about an axis, every point on it moves in a circle. Think of a merry-go-round, a car wheel, or even the Earth rotating around its axis. Now, instead of linear quantities like displacement, velocity, and acceleration, we use the rotational equivalence. And here's the link between them. V is r plus angular velocity, and a is equals to radius twin where r is the radius of rotation. Easy, right? Now here's where things get exciting. Bank curves, even notice how racetracks are highly stealth at curves. That's not just for style, it's physics in action. On on a bank curve, the route is titled at an angle theta. Angle. The forces acting on the car are weight, weight, mg downward. So, and normal reaction is in perpendicular to the force. Sir. Friction sometimes negligible, it is frictionless bank. So, for a frictionless bank curve, the vertical and horizontal forces like this. Horizontally, centripetal force is N sine theta is equal to mv squared over r. Divide the two, is it tan theta is equals v squared over rg. This means the ideal banking angle theta depends on the speed, radius, and gravity. Cool, right? So in bank curve, here a problem in a bank curve. A car is traveling on a frictionless bank curve of radius 200 meters. So if the curve is banked at the angle of 15 degrees, at what speed should the car travel in order for it not slide up or down? What angle should the road be banked for a car to travel at a speed of 30 meters per second without sliding up or down in the above of friction? So we're gonna use the formula. So for A, we're gonna use the formula. We answer A. We're gonna use the formula for frictionless bank curve. The ideal speed is given by V is equals to rg tan theta, where V is the ideal speed, meter per second, R is the radius, meter, and G is 9.8 meter per second squared, and theta is the banking angle. So we're gonna use this formula in the problem A. So we're gonna use R given is R is 200 meter, and our theta is 15 degrees. RV is equals to 200 times 9.8 tan 15 squared. Tan 15. So we're gonna solve it using our scientific calculator. 0.8 tan 15 is equals to 22.9 meter per second. So the answer of letter A is 22.9 meter per second. So for the B, let's answer for the B. What? I'm going to erase it because we don't have a space left. So in B, the question B is what angle should the road be banked for a car to travel at a speed at 30 meters per second without sliding up or down in the absence of friction? So for letter B, we're going to use this formula. Tan theta is equals to V squared over Rg. Our given is Rv is 30 meter per second, Rr is 200 meter, Rg is 9.8 meter per second squared. So we're going to substitute it. Tan theta
is equals to 30 squared, that is squared, over radius, and 9.8. So, to our 30 squared is 900, and 200 times 9.8 is 1960. So, after that, we're going to multiply the 900 divided by 1960. We're going to use our calculator. So, our answer here is 0.4459. Our answer. So, here's our answer. 0.459. So, the next step we use is we're going to use another formula. Now, tan, our answer here. No. 459. To make sure to get the correct answer, we're going to use tan power of -1. We're going to put our answer here, that they are divided 0.459. So we're going to use a calculator to get the full answer. So palm shift tan 0.459. And the answer is 24.6. Convert na to siya. Ang 6 may siya og 7. So the answer for letter B is theta is equal to 24.7 degrees. That's the answer. That's all for the band curves for letter B. So let's move to rotational motion problem. Our problem is about a wrench. A wrench is being used to loosen a bolt if the wrench starts at an angular position 2 of pi per square rad and rotates counterclockwise 1/3 revolutions. What is the final angular position of the wrench in radians? So first we're gonna do is we're gonna look at it given. Now here's our given. Theta is equal to 1.5 rad, as stated in the problem earlier. Theta is equals plus 1/3 revolution. So we're gonna convert revolution to radians. 1 revolution is equals to 2 pi rad. So theta is equals to 1/3 and 2 pi is equals to approx of, we're going to convert this 1/3 into pi is equals to 2.094. Since it's counterclockwise, we're going to use this formula. 0 theta is equals to theta 1 times is equals to 1.5 plus this one 2.094. 1.5 plus 0.94. I'm going to use a calculator. Is equals 3.594 rad. So the answer is 3.594 rads. So here's our answer. Here's the answer of the rotational motion.
That's it for today's vlog. If you found this helpful, don't forget to like and subscribe and share it with your classmates. Until then, keep learning, keep exploring, and stay curious.